Okay, in question 7 we have a bit of proof. So a student notices that when he adds two consecutive odd numbers together, the sum always seems to be the difference between two square numbers. He claims that this will always be true, and we are given his attempt to prove his claim. So, for step 1, we've checked that he's checked the first few cases, although I'm not sure what happened to 1 add 3, but never mind. So, it works for all of those. Step 2, he's used a pattern to predict and check a larger example. So, that has also worked. Step 3 is his conclusion. So he's saying the first few cases work, and there is a pattern which can be used to predict larger examples. Therefore, it must be true for all consecutive odd numbers. Part A asks us to explain what is wrong with the proof. So, the problem with the proof is it is not a proof. All that he has done has checked that it works for a few examples. So, all that he has proven is that it does work for those examples. So, we should say something along the line of his method is not exhaustive, so does not prove the claim is true for all consecutive odd numbers only the ones he tried. Cool. Okay, then for part B and for 3 marks we want to prove that the student's claim is true. So, two consecutive odd numbers. Let's first of all work out how we could write those down. So, if our first odd number is 2n plus 1, then the next odd number is 2 more than that, so it's 2n add 3. So 2n add 1 and 2n add 3 are two consecutive odd numbers for integer n. And then our sum of two consecutive odd numbers is 2n add 1 add 2n add 3. Now that gives us 4n add 4. Okay, now this next bit is not at all obvious, so we need to go back to his attempt at a proof and spot that pattern that he mentioned. So, when you get to the difference between the square numbers at the end, there is a pattern. The square numbers are two numbers apart. So we got 3 squared minus 1 squared, 4 squared minus 2 squared, 5 squared minus 3 squared. And then we've even got, with this bigger one, 52 squared minus 50 squared. So let's say n squared is a square number, and the square number that would be the second one on from n squared would be n plus 2 squared. So just like 3 squared and 5 squared, 3 and 5 are 2 apart, n and n plus 2 are 2 apart. So let's say n plus 2 squared is also a square number. And if we find the difference between them, well, n plus 2 squared minus n squared is n squared add 4n add 4, so that looks familiar. That's our sum of 2 consecutive odds. And then if we're finding a difference, we got our minus n squared on the end. So that is equal to 4n add 4. So the sum of 2 consecutive odd numbers is indeed the difference between 2 squares. Cool.